Hello world, microcats! Today in the video we will consider the operation of an Rtc module or real-time clock. You will also be prompted to use a simple calendar. We assemble the electrical circuit using the Stm32 display as well as an additional element, a 3V lithium battery. The first thing you need to check a lithium battery, for which a case was purchased, to which I soldered the wiring. The battery is connected to the contacts GND and 3VB, 3V battery. We look closely at the screen and turn on the power. When working with Rtc, the controller loading can be delayed per second. If you have problems with the 32 kHz crystal resonator or the capacitors C9, C12, when the controller may freeze. The battery is now disconnected. The current time is 23 hours 59 minutes 00 seconds. The current date is June 30 as 2021. Remember the time now and turn off the power. I remind you that the battery is not connected. As you can see, time has gone astray and the countdown has started from the beginning. In order for the time countdown to occur, an external battery power supply is required. Connect the plus to the 3VB pin. Now we look at the time. We turn off the power. As you can see, time goes on. See if the date changes. The date has changed, became 1 July as 2021. Then turn it off. Wait a while, turn it on again. You look that the date and time are not lost. Now turn off and unplug the battery. We see a long load of a controller. This is a waiting cycle to the start of a watch quartz. As you can see, the time and date are lost. Thus, a prerequisite for the operation of a Rtc module is the presence of an external battery. Thus, power will always be supplied to the module. Note that the VBAT voltage is between 1.8 volts, 3.6 volts. Let's move on to programming. We include the necessary header files. We declare defined for working with SPI and Rtc modules. Rtc backup is a value that acts as a flag that the Rtc module is initialized, it is fully configured. GT0 is a constant for special function to convert the number of seconds to a calendar day and vice versa. We switch to an external quartz resonator. We configure the PLL module. We configure frequency dividers for internal buses. We turn on the clocking of a periphery. To work with RTC, you need access to a special backup memory. This is not an EEPROM. These are registers that can be powered from an external battery. We check the initialization flag of the RTC module. Let's start setting up. Disable writing to backup registers. Let's switch to clocking from an external 32 kHz crystal. We are waiting for its launch. It is in this cycle that the controller freezes if you use low quality resonator or capacitors. Pay attention to the recommendations from ST. Functions that work with RTC must be paired with the RTC wait for last task function for proper synchronization. The first time you turn it on, you also need to synchronize with the APB bus. We enable the every second event for the interrupt to work. We enter the configuration mode and set up the prescaler and the initial value of the seconds counter. We have a counter of seconds set at 23 hours 59 minutes 00 seconds. The date is June 30 as 2021. We write down the flag that the initialization was successful. If the power failures or the controller rebooted but an external 3V battery is connected when this code is executed, we prohibit writing to the backup registers. We enable the every second interrupt. Next comes the standard initialization of pins for the opto relay, SPI module and display lines. SPA and DMA settings are similar in the video about working with the Stm32 display. When configuring interrupts, please note that they must be enabled at the end of a full initialization of all peripheral devices. We initialize the screen and show graphic and string information. Launch a simple loading screensaver. Now you can start the interrupt from the Rtc module. Special functions for working with time and date. The indicated links contain articles with originals. Here, adaptation for your tasks is presented. In the Rtc interrupt, check the event flag and clear it. Since the call between interrupts is quite long, 1 second. In this second we show information on the screen right in the interrupt. We translate the value of a seconds counter into the daytime structure and show the lines with this information on the display. Interrupts from DMA channels work on the principle of made and then turn off. Let's see how the Rtc module works if a controller reboots. As you can see, time is lost. Let's connect the external battery now. And now we see that the time and date are working correctly, regardless of reboots or controller power supply. With the help of such a module, you can update the clock in your car. In addition, the display always you can to show it on a small picture. Subscribe, Microcat.